All right, so the next thing we're going to do is introduce tree diagrams into probability. Now, if you recall, we introduced tree diagrams back in chapter 6 when we were when we were looking at the multiplication principle, just to sort of illustrate how can get all possible outcomes by drawing a tree. All right, trees come in handy in probability, and so that's what I'm gonna introduce next. There's a definition here, finite stochastic process. All right, so we're gonna study finite stochastic processes. All right, it sounds kind of fancy, but stochastic just means it's random. Finite means there's just a fixed number of stages in this stochastic process. So we have a finite number of events that happen, and their outcomes are determined stochastically, right, randomly. All right, so there's a finite number of stages. Let me underline that. We have a finite number of stages. The probabilities of each stage depend on the preceding stages, basically. All right, so let's take a look at an example of a finite stochastic process. In this example, we have 2 cards drawn without replacement from a well-shuffled deck of 52 playing cards. This sounds familiar. This time, though, we want to know what's the probability that the second card is a face card. Okay, we don't really care about what happens on the first draw, but the probability of drawing a face card on the second draw depends on whether we drew a face card on the first draw, right? Because that'll change the number of face cards that are left for the second draw. Okay, so let's draw a picture, a tree diagram of what that looks like. All right, so our first stochastic event, our event of chance, is drawing the first card, right? I'm going to call that F1. So that F1 will be the event that we draw a face card on the first draw. Okay, and F1 complement will be the event that we do not draw a face card on the first draw. Okay, right, and I'm concerned about that because that's going to determine what the outcome is for the second draw. All right, so now the second draw is the next stochastic event, right? So we're going to draw another card, and it's either going to be a face card or it's not going to be a face card. Okay, so I can draw a tree that looks like this: face card, or on the second draw, or not a face card. All right, so that's our finite stochastic process, right? Where we've got 2 draws, we got two stochastic events, and the first one is just the first event of chance is just drawing the first card. The second event is drawing the second card. Okay, so now let's take a look at what the probabilities are. Now on the first draw we have 12 face cards, and out of 52 cards in the deck, right? Because we haven't drawn any cards yet. That's the probability of a face card on the first draw. Okay, what's the probability of not drawing a face card on the first draw? Well, we have 40 other cards out of 52. So there's a 40 out of 52 chance that we will not draw a face card. Okay, I'm going to put these probabilities on the branches of the trees. Okay. All right, so now we're going to go on to the second event of chance, right? The second stochastic process, right? So, or stochastic event. All right, so now this event, if I follow this branch of the tree where I'm going down this branch, and then I'm going down this branch, right? So now we've drawn a face card on the first draw, and we want to know now what's the probability that we draw another face card, right? So this is going to be the probability of F2, right? Draw a face card on the second draw, given that F1 has happened. All right. So we have 11 face cards left out of now 51 cards, right? Because we already drew 1 card. We're not putting them back. All right. And so now let's look at the next branch. All right, now we want to know, given that we've drawn a face card on the first card, right? So we're in this branch here. What's the probability that we do not draw a face card on the second draw? Well, there's still 40 cards, 40 non-face cards in the deck, but now we only have 51 cards. Okay, so the probability of not drawing a face card on the second draw, given that we drew a face card in the first draw, is 40 out of 51, right? I could write that out. Probability of F2 complement. I don't have much room though, so whoops. Given that, given that F1 has happened, but that's 40 out of 51. Okay. All right, so now let's keep filling out this tree. All right, so now if we trace down this next branch, where now we do not draw a face card on the first draw, and we draw a face card on the second draw. Okay, so what's the probability of drawing a face card on the second draw, given that we did not draw a face card on the first draw? Well, if we didn't draw a face card, all 12 of those face cards are still in the deck, and there are 51 cards. So the probability of drawing a face card on the second draw, given that we did not draw a face card on the first draw, is 12 out of 51. All right, and our last branch here then is the event that we do not draw a face card on the second draw, given that we did not draw a face card on the first draw. Okay. Or sorry, yeah, did not draw a face card. Okay, so we had 40 non-face cards. We drew one of those non-face cards, and now we only have 39 face cards left out of 51. So that would be the probability of drawing a non-face card on the second draw, given that we drew a non-face card on the first draw. All right, so let's see. What are we trying to do here? What's the probability the second card drawn is a face card? All right, let's figure out where those events are. It can happen in a couple different ways, right? It can happen here, right? We drew a face card and then another face card. Or it can happen here, right? Where we drew a non-face card and then a face card. So there's two different ways that event can happen, all right? Two separate ways. So if we want to find the probability of F1 and F2 happening, all we need to do is multiply the probabilities along those branches. So it's 12 out of 52 times 11 out of 51, right? That's just using that product rule. And when I do that, let's see, I'm going to put it in my calculator. I got 0.04977. Okay. The other probability I'm interested in is this one, where I did not draw a face card on the first draw, and then I drew a face card on the second draw. Okay, so the probability of that is, again, I'm just multiplying the probabilities along these branches. So the probability of, drawing a face card on the first draw, or sorry, a non-face card on the first draw is 40 out of 52, and then the probability of drawing a face card on the second draw, given that I did not draw a face card on the first draw, would be 12 out of 51. Okay, I'll put that into my calculator. I get 0.188100. So now to figure out the probability of a face card on the second draw, it can happen in either one of these different ways. So I'm going to add the probabilities, right? These are two mutually exclusive events, right? They're not going to overlap. They can't happen at the same time. Either I draw a face card and then another face card, or I don't draw a face card and then I draw a face card. Okay, so I can add these probabilities. So 0.04977 plus 0.188100. Add that up. I get 0.23077. Okay, so that's my final answer. About a 23% chance of drawing a face card on the second draw. Alrighty. Well, I'll meet you in the next video.